Hello, everybody. Okay, so today we are doing the practice test. So if you have it, it is best if you try to do it first without me and then come back to the video to see how you're doing, right? That would give you the best information on if you're ready for our test. This is for Module 7. So here we go. All right. Number 1, it says, how is the function g of x equals 3 square root of x transformed from its parent function f of x equals the square root of x? So let's start with the parent function. If you know what the parent function of square root of x looks like, that could help us, because it looks something like this. And it looks like that because it cannot be a negative number inside the square root sign. So from there, we need to decide what the difference is between this, and the difference is the 3, right? So we need to decide if the 3 is on the outside or the inside of the grouping symbol. And it is on the outside. So our 3 is on the outside, right? Inside would look like this. Inside would look like square root of 3x. So that's the difference. So ours is on the outside of the grouping symbol, right? You may remember our little saying that horrible things happen inside. And that's to help us remember that horrible things happen inside, right? So that's H sound, so that's horizontal, right? And it comes from our equation that looks like this, b of x, or I suppose it's more accurately written 1 over b of x minus h plus k, right? Where the horrible horizontal things happen inside the parentheses, but then the outside, so the a and the k are vertical changes, all right? I think we talked about it and we said, oh, AV, we live in the AV, and A is a vertical change. So since we have a 3, which is on the outside, and it's going to be a vertical change, so it's going to be one of those. But let's talk about how we would expect a 3 to change our graph. So a 3 is a whole number, so we would expect things to get bigger when you multiply by a whole number. If it were inside, we would expect it to get bigger or stretch, but horrible things happen inside, so it would get changed to the opposite of what we expect, so it would be a compression. But we are not horrible and inside, we are outside, so we would get what we expect, so it's going to be one of the stretched, right? So a whole number, a 3 on the outside, is going to stretch the graph, make it bigger, and so the one that has both stretched and vertical would be the bottom one. Number 2. So for number 2, I find it difficult to find my domain and range based off of the coordinate pairs set up like this. So I like to make an X and Y chart, right? A T chart. I want one for the F of X, and then I'd like another for the inverse of X, right? I'd also like to remind us that X represents the domain and Y is the range. So here the X is the domain and here the Y is the range. Now I can just put each of these coordinate pairs into the chart. So I'll go -6, 3, -2, 0, 1, -2, 4, 3, 5, 7. And then in the inverse, the whole point is that we would put the range of the first one in as the domain here. So we're going to end up with the opposite, right? Just the reversed or the inverted coordinate pair. So we go from -6, 3 to 3, -6, from -2, 0 to 0, -2. You should pause and try to finish without me. Welcome back. -2, 1, 3, 4, 7, 5. If it helps you to have these underlined so that you can see them together, you could do that. If you prefer the arrow to show that one is becoming the other, that's also lovely. All right, and then the first question says, the domain of f is -6, right? And we're going to check that. We're going to go to f, and we're going to look down the domain, and we have -6, -2, 1, 4. Oh, it should be 5, but this one has a 3, so that does not belong. So the way it is, this is false. I looked at the domain, I compared it to what they had as the domain. They were not the same, so it's false. The next one, the range of f is -2, 0, 3, 7. So I come to the range. Ooh, but it doesn't start with the 3. Does the order matter? Well, let's write two of our rules that we have for domain. One is that when we're using set notation with these brackets, we have to write the numbers from least to greatest inside those brackets, inside the set notation. And then another rule we have is that we do not write duplicates twice, right? Or repeats twice. So we do not write repeats twice. We write them, but only once, right? So let's see what that looks like. All right. So I'm looking at the range of f of x. So we have a -2. I agree. We have a 0. I agree. We have a 3. I agree. We have a 7. I agree. They didn't write the 3. Oh, wait, because we already have it and we do not write repeats twice. So this is correct for our range. Now let's go to the domain of the inverse, right? So here we have -2. Again, they have to be in order from least to greatest in our brackets, but not on our charts. Sometimes it's helpful and we'll do it, but in this case we did not. So -2, 0, 3, oh, and the 3 again. But that's fine. We don't write it twice. And the 7. Yay. So that is correct. Also, if you recognize that the range of the first one is going to become the domain of its inverse, we could have just looked to see if these were exactly the same, which they are. The last one, we want to look at the range of the inverse. So we're coming all the way to the right. We have -6. I agree. -2. I agree. 1. I agree. 4, I agree, and they forgot the 5. So it should have looked like that. So this one is false because they forgot the 5. Well, let's go to numbers 3, 4, and 5. So 3, 4, and 5 are all here together. I should have organized them like 3 and done the work below it, and then 4 done the work, and then 5 done the work. So I apologize that the worksheet isn't set up great. But let's see what we can do. So I'm going to start with f composed of g of x. So that means I write down the x, 6x minus 2. I draw an arrow to the x because that's where I'm going to plug in g, 2x plus 5. And then I rewrite it. So I get 6 times 2x plus 5 minus 2. From there, I'm going to distribute. So I distribute the 6, and we get 6 times 2x is 12x. 6 times 5 is plus 30. And then the -2 is just hanging out there. Now I can combine like terms. The 30 minus 2 is basically a first grade problem snuck into our Algebra 2. So we get 12x. 30 minus 2 would be plus 28. And that is our answer. Super helpful if you can put your answers into boxes like that. It helps with making grading more accurate and quickly. And then I don't look at the wrong part of your stuff to do it. All right, I am going to separate my stuff like this, and I'm going to do number 4 in this column. So number 4 says, what is the inverse of g of x? Well, let me start by writing g of x equals 2x plus 5. To do the inverse, I want to solve for x, so I'm going to go -5 to both sides. We're going to change the g of x to y. -5 equals 2x. I suppose I could write g of x over and over and over again, but that seems difficult. So now I have 2x. The 2 is multiplying to the x. The opposite of multiply is divide, so I'm going to divide. A fraction bar does mean divide. What you do to one side, you have to do to the other. I do love a 2 over 2 because 2 divided by 2 equals 1. So we end up with x equals y minus 5 over 2. Be careful because some of us are forgetting to then invert, right? The whole idea is that we're finding the inverse. So we can invert or trade or swap x and y. So I'm going to put the x where the y is and the y where the x is. So I get x minus 5 over 2 equals y. And that is our final answer there. I would like to point out that another correct answer could be x over 2 minus 5 over 2 equals y. In this situation, they are both equally correct. If the negative 5 over 2 could reduce, like if it were negative 6 over 2 and would become minus 3, you could argue that doing it that way would be more correct. But I'll take it either way. All right. And then our last one is, what is f composed of g when when x is negative 2? So we start from the inside first, so we do this one first. So I'm going to write g of x equals 2x plus 5. Oh, hang on. I don't want g of x. I want g of negative 2. So I'm going to put a negative 2 wherever there's an x. So I get 2 times negative 2 plus 5. And let's go ahead and write that in words over here. So you're going to plug in negative 2 for x in the g of x equation. That's our first step. Let's give that a bullet. Maybe even do a little line from the negative 2 to where we can see the negative 2. Okay? Then we get 2 times negative 2 is negative 4. We still have a plus 5. Negative 4 plus 5 would be 1. So we have g of negative 2 equals 1. Now we're going to take this answer and plug it into f of x. Okay? So let's write that down as a step. Plug in that answer to f of x. All right. So I'm going to come up here to do that. All right. So we have f of x equals 6x minus 2. Oh, wait. I don't want f of x. I want f of 1, right? Because the g of negative 2 equals 1, and now I'm plugging the 1 in for f of x. So we get 6 times 1 minus 2. I feel like I need to be closer. All right. 6 times 1 is 6, so f of 1 equals 6 minus 2. And now, after all of that intense Algebra 2 work, we are left with a first grade problem. 6 minus 2 is 4. And that is your answer for part 5, for number 5. Okay, flipping it over. All right. So, we will start with, consider the function f of x equals x plus 4 squared minus 1. Ooh, I'm going to write the word quadratic above it because I see quadrat. Oh my, quadrat. Let's try spelling correctly today. Can you tell it's late on a Friday afternoon? All right. Quadratic. It's a quadratic, so I wanted to write the word so we'd know to look in our notes under quadratic inverses, right? So consider the function f of x equals x plus 4, quantity squared, minus 1. Use this information to answer the questions 6, 7. What is a function for f inverse of x? So we want the inverse of this. So we start with f of x equals the quantity x plus 4 squared minus 1. We're going to add 1 to both sides, and we're going to change that f of x to y just for simplicity. From here, I have a quantity x squared. I had a few students who wanted to go distribute the squared to the 4 and to the x, and we cannot because we actually have to do the parentheses first, but we cannot add those. So then if we were going to square this, we would have to do x plus 4 times x plus 4, because that's how squares work, and then we'd have to FOIL it or do the box method and get all that out there. But we don't need to do any of that because we want x by itself. So we can take the square root of this whole side. And we love doing that when we have a square, because now this quantity squared cancels out the whole radical sign square root, and we are left with x plus 4 on that side, which we can deal with an x plus 4. But what we do to one side, we have to do the other, so we do have to take the square root of this whole other side. So on this side, we have y plus 1, all under the square root sign. Make sure that even the 1 is under the square root sign. Okay, from there, we're going to subtract 4 to both sides, and we get the square root of y plus 1 under the radical sign minus 4 not under the radical sign equals x. Beautiful. Now that we have the x by itself, let's go ahead and do our inverse, right? Inverse or trade that x and y. So I'm going to do square root of x plus 1 minus 4 not under the square root equals y. And this is our beautiful answer. Now, here it's saying what is the domain of the inverse of x. So like it's asking what does the domain have to be to keep us out of the imaginary numbers, not repeating things so that it can be a function, right? So the only like restriction we have, or the limit we have, is created because of what is under that square root symbol, okay? So that's the only part that has rules. Like it has, whatever's inside that square root has to be a positive number. So we're going to come over here and we're just going to say, fine, well, I can even do it underneath. If the square root of x plus 1 has to be positive, then we would write that as it needs to be greater than or equal to 0. Okay, well, actually, it's just the inside, like even before we take the square root. So let's just write x plus 1 has to be greater than or equal to 0. And now we can subtract the 1 from both sides, and we would get that x would have to be greater than or equal to a negative 1. And that is this answer choice right there. Now, I do want to take a little sidetrack here to remind us why it has to be a positive under there. Because if you wanted to take the square root of 25, you're like, cool. That would be, I mean, if you want to be all official, it's either plus or minus 5, right? The reason that's true is because 5 times 5, so positive times a positive, is going to equal 25. Or a negative 5 times a negative 5 is going to equal 25. Okay? But what if my problem was asking what is the square root of negative 25? So what are two numbers that multiply together, exact same number, that would give us negative 25? Well, 5 times 5 doesn't work because that gives us 25, a positive 25, so that doesn't work. Negative 5 times negative 5 doesn't work because that gives us positive 25, so that doesn't work. Oh, wait. We can do negative 5 times 5 would give us negative 25, but that doesn't work because those two are not the same number. One's a negative, one's a positive. You have to have the same number. So the answer to this would be plus or minus 5i, where I is an imaginary number, but we are not dealing with imaginary numbers for graphing in this instance, so can't be it. So that's why we need whatever's under the radical sign to be a positive number. So that's why it has to be greater than or equal to 0. You only have to set up the part that's under the radical sign. The -4 does not matter. Okay? One more side quest. On your test, I think you can translate that to I know. I know that you actually end up with something like this, -3x minus 6, something like that, okay? And we need to make sure that it is greater than or equal to 0, okay? Oh, the radical sign doesn't matter. I just need to make sure everything inside is greater than or equal to 0, so we've got that. Then we can go plus 6 to both sides. Beautiful. -3x is greater than or equal to positive 6. Then we've got -3 times x. So the opposite of times is divide. So we're going to go divide by -3, divide by -3 to both sides. This is beautiful because -3 becomes 1x. But look out. Here's the thing. You have to flip your sign. It's one of those random rules that we probably don't practice enough. So you got to flip your sign. So instead of greater than or equal to, now it's going to be less than or equal to. And then 6 divided by -3 equals -2. So x is less than or equal to -2. And this would be your restriction for that one. So let's write those rules down so we make sure we have them. Okay? So when you multiply or divide by a negative, switch the inequality sign. Now be careful. You don't have to do it if you're subtracting 6 or subtracting 3. It's only when you multiply or divide. And then you have to flip that sign. Now we do have a couple of options here. Like you could say, absolutely no way am I going to remember that. What are my other choices? So I did not leave us much room, but I'm going to write it again up here. If we start here with this -3x minus 6 is greater than or equal to 0 part, okay? Your brain, just because we've done it so many times, you're going to want to add 6 to both sides. But if you can slow down and notice that your x is negative and be like, ooh, I do not want to deal with a -3x, we could add 3x to both sides instead. And we would get -6 is greater than or equal to 3x. Now we divide by 3, divide by 3. No flipping or switching necessary because we're not dividing by a negative. 3 divided by 3 is 1, so we get x has to be less than or equal to -6 divided by 3 is -2. This answer would also be correct. Notice they are the same. X, pointy side, so we say less than -2. They are exactly the same. All right, check it out. Doesn't matter how you do it. Okay. I suppose the only way this would be wrong is if the answer key had this and the person grading did not recognize that these were both equal. So if you're ever not sure, bring it back to your teacher. Obviously, bring it back to me if you think I make a mistake, and we can always double check those. All right. I'm on number 8. I cannot believe that number 8 was given to me as an option for a test question, but here we are. It is saying you had x plus 2 equals 4. How did you get to x equals 2? We should notice that we did -2 to both sides. 2 minus 2 is 0, so we're left with just x. 4 minus 2 is 2. So that would be this option, and let's go ahead and make that correction. Hopefully I make it on the worksheet before I post it here. All right. Here we go, number 9. 9 and 10, we're almost done. All right, number 9. Solve the equation and identify the restriction. Please, 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 this is worth 2 points, so try not to forget to do the second part, right? All right, so we're going to solve the equation. We have the square root of x plus 4 minus 3 equals 0. The minus 3 is not under the square root, so I'm going to add it to both sides. Then I get x plus 4 square root equals positive 3. Now, finding the square root of x plus 4 is going to be impossible because I don't know what x is. So what we're going to do here is we are going to square this. Because if I square it, then all of this times itself, I could just take out of the square root symbol, and we would get left with a beautiful x plus 4, which I can totally handle, right? We do this because this square cancels with the square root sign, and we get just the x plus 4 left over. Now, don't forget, what you do to one side, you have to do the other. So now I have 3 squared. 3 squared means 3 times 3, which is 9. From there, I can go x plus 4. We're going to go minus 4 to each side, and we get x equals 9 minus 4. Look at that, first grade math in our Algebra 2 again. 9 minus 4 is 5, and that is the answer to the solve the equation part, right? Thank you for putting the box around it, super helpful. But now we have to identify the restriction. What part matters in identifying the restriction? Yeah, just the part that's under the radical sign. So we get the x plus 4, and it has to be greater than or equal to 0. Wait. The radical sign doesn't matter. It's just the inside of it. So the x plus 4 has to be greater than or equal to 0. And now we can solve for x. I do that by subtracting 4 to both sides. Ooh, I have a negative 4. Do I need to flip the sign? No, because we are just subtracting 4. We are not multiplying or dividing by 4. So we get x plus 4 minus 4 is 0 is greater than or equal to negative 4. And that is the second part for number 9. All right, number 10, here we go. Solve the equation, the cube root of 4x minus 5 plus 2 equals 0. The plus 2 is not under the cube root sign, so I'm going to move it first. Minus 2, we get cube root of 4x minus 5 equals negative 2. Make sure that 5 is under that radical sign, right? All right. What can I do? I would love to add 5 to both sides, but I can't because it's in like a grouping symbol, so I can't move the 5 yet. So it's this cube root that's causing us problems. So just like up here, when we had a square root causing us problems, we squared it. When we have a cube root causing us problems, we are going to cube it, or take it to the third power. What you do to one side, you have to do to the other side. So we will also cube our negative 2. And then this cube cancels the cube root, and we get 4x minus 5 on one side. This is negative 2 times negative 2 times negative 2. 2 times 2 is positive 4 times negative 2 would be negative 8. Now we can move that 5. We move the 5 by adding 5 to both sides, and we get 4x equals negative 8 plus 5 will be a negative number, a negative 3. The 4 is multiplying to the x, so the opposite of multiply is divide. So we get x equals negative 3 over 4. And then just before we leave, I want to make sure that I point this out. So looking at this step where we had the cube root of 4x minus 5 equals negative 2, it's okay that this radical sign can equal a negative 2 because we have a cube root. and a negative times a negative times a negative will give you a negative. So that works out fine. But if this had been 4x minus 5, the square root of it equals negative 2, this would be no solution. Because there is nothing that will multiply times itself and give you, like, it just doesn't work. You can't do it. It goes back to the examples with the 25 I was giving you. Like, because, like, the square root of 4 is what would equal 2, right? But it doesn't equal negative 2, so you can't do it. All right? That's it. Come and take your test if you haven't already. Work on your test reflections if that's what you need to do. And I will see you on the flip side.